Welcome to this video on piecewise functions. So what are piecewise functions? Well, a piecewise function, like any other function, has to have an input and an output, but it also has to be defined on domain, right? Okay, this is important when it comes to piecewise functions. So what actually is a piecewise function? Well, a piecewise function, all it is a function that's defined on a sequence of intervals, okay? And the reason I wanted to highlight that it needs to be defined on the domain is because really your domain is just whatever intervals you have defined it as, okay? So let's look at the example of absolute value of x. So you likely know what the absolute value of x looks like, right? Looks like this. Okay, but if, say we weren't able to use these absolute values, right? Say we couldn't use this, and it instead was just x. Well, x is just going to be like that, right? Not going to have that anymore. So how can we write a function, a piecewise function of absolute value of x without using that absolute value? Okay, this is where the piecewise functions come in. So you're going to say f of x equals a large bracket, okay, and this is really to contain just all your different functions, and you're going to go negative x, comma, x less than 0, 0 at x equals 0, and x greater than 0, okay? And now we're going to take all three of these, right, 1, 2, 3, and we're going to plot them on this graph, okay? So let's do the first one. We're going to have negative x, so that's just going to be like this, right? And this is going to be 1. And then we're going to have 0 right here. So we can label that as 2. And then we're going to have positive x. So this is going to come back up like so. And now you're going to have absolute value of x. Right? This is just another way of writing absolute value of x. But we'll dive into examples that are specifically piecewise and can't, be written. Take this shortcut where you can just write absolute value of x. So let's do that. Alright, so let's move on to our example here. So we have f of x equals x squared from negative 2, and let's just say negative x from um, 5. Okay, so what's the difference between this and this? Okay, most of you are probably going to recognize that this is, if we had an x here and some number, right? X is going to be greater than or equal to, and in our top case, this case, it's going to be greater than. But what does that correlate when we're graphing this on the graph? Is there any difference on the graph between these two? Okay, on the graph, this is going to be an open circle when we get to that point. For this, when it's or equal to, it's going to be a solid dot. Okay, with that being said, let's graph this function here. Okay, so we're going to have x squared from negative 2 to 2. If you don't know what those values are, let's just make a data table here. And this is for x squared. Okay, so let's plug these values in. We're going to have 4, 1, 0, 1, and 4. Okay, let's plot these values on our graph here. Okay, negative 2, 4, negative 1, 1, 1, 1, 2, 4. Okay, and remember what I said about these less than or equal to or less than signs. So we have -2 with an equal sign, so this is going to be filled in. It's going to be solid. And then we have x is less than 2. So this will be an open circle. Okay, hopefully that makes sense. And then now we have -x from 2 to 5. Okay, so 2 to 5, this is just going to look like this. Right? And this whole graph is f of x. Okay, and if we want to be specific, this is x squared, right? And then this is -x. But really this whole graph is just your function, f of x. It's just your piecewise function. Okay, let's move on to the next example. And our next example here is going to be f of x equals 4 minus x squared, and that is defined from x less than or equal to 1, and now we're going to have x squared plus 2x, and that is going to be defined from x greater than 1. Okay, so let's graph these. First, let me find some data tables, or make some data tables for these. So this is going to be the data table for 4 minus x squared, x and y over here, and it's defined from x less than 1. Okay, so I'm probably just going to plot a few values to the left of 1, 2. Well, I guess we don't need that 2 actually. Okay, so 4 minus -3 squared. Okay, so it's going to be 4 minus 9. This is going to be -5. 4 minus -2 squared is going to be 0. 4 minus -1 squared is going to be 3. And that's going to be 4. This will be 3 again. Okay. And now let's do the same thing for our x squared plus 2x. Okay, and that is defined from anything greater than 1. So we don't need a whole lot of points, really as many points as we want to plot, right? Just need a couple. Okay, so 1 squared plus 2 times 1 is going to be 3. 2 squared plus 2, so it's 8. It's going to be 15. It's going to be 25. Okay, so let's plot these. Let's plot our 4 minus x squared, and it has a limit right here, right? At that 1. So we have an origin at 0, 4, -1, 3, 1, 3, and we know this is going to be a closed dot right here because it is less than or equal to. And let's see what else we got here. So we got -2, 0 and -3, 5. -3, -5, excuse me. Okay. And we can just imagine this goes down indefinitely since there's nothing saying it doesn't. Remember, closed dot. Okay, and now we have our x squared plus 2x. So let's plot that. Our first point is at 1, 3, which is also an open dot. But if you have an open dot and a closed dot at the same point, then it's really just going to be a closed dot, right? Doesn't really matter. Okay, so I have 1, 3, 2, 8, 315. Yeah, it's just going to go up here. So it's going to go up very rapidly up there. Okay, so there's your next piecewise function. All right, I took the liberty of copying this graph down before I start this example, just to save some time. So if you'd like to pause this video and copy this graph down, please do. Okay, so we see this as a piecewise function, and I see a couple different things right off the bat. I see a constant up here, right? This is a constant. This looks to me like it's x. This red is x, and this looks like some sort of form of a function, negative x plus something, right? I imagine the y-intercept's going to be up here somewhere. Okay, well, with that said, let's attempt to try to start writing this function out. Okay, so we have y equals 7 up here. So y equals 7. Maybe we should do y equals 7, and it's from negative 7 less than or equal to x, and it goes to negative 3. Okay, what about our red here? This is just x, and this is from negative 3, but we have an open circle, so it's just less than, and this goes all the way up to 4. About this yellow. Okay, well, I see the slope is just negative 1, so you can either do two of three. We'll do one of two things. You can just go like this. Okay, I know my y-intercept is 3, or you can try to find the y-intercept, which, remember this. Okay, remember this equation. This is how you find the equation or the function for something that's linear. So we plug in the points that we know of y initial, x initial, and our slope. So we have y, and we know we have our point 7, negative 4. So we're going to have, and our m is negative 1. Okay, so I'm just going to move this up here. So it's going to be y plus 4 equals negative x plus 7. Okay, minus the 4, and you're going to have y equals negative x plus 3. Okay, so they match up. So negative x plus 3, and this is going to be on the interval of 4 all right, and that is a piecewise function. Remember, if anything is defined, then there must be an input and an output, and in this case everything is defined and it passes the vertical line test, as we are not hitting multiple points as we draw our vertical line. So this is a function, right? This is a point. It's defined, but this is not a point, so it goes right through it. This is defined, but this isn't, so it goes straight through it. And there's nothing here, but this is defined. Okay. But what if this was filled in right here? Would this be a function? And the answer is no, because it hits a point twice. Okay, so keep that in mind when you're doing these piecewise functions. Whether you have two filled in circles, right, that are vertical with each other, right, they're in line with each other. that will not be a function. Okay, and I also took the liberty of writing this graph out already, so take a minute to pause this video and copy this graph down. Okay, so we are going to have 6 from 0 less than or equal to x to 2, and I'm going to kind of go a little faster through this one because we are just looking at a whole bunch of constants. But I want to include this example so you can really see how the open circle and then less than or equal to works, okay? Because that's kind of going to be what trips students up the most. Okay, so we're just writing out our functions here. We have -3, and that is defined from 4 to 6. And let's not forget that blue point all the way up there, and that is just a constant 7. And it is defined at x equals 6. Okay, so when you have a solid point, you're just going to say x equals, whatever that value is. Okay, and so if we do the vertical line test, let's just put it in purple. Yep, passes, 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 passes. Okay, so I hope that makes sense to you. All right, and we have another example here all right now, so take a minute to pause this or just feel free to follow along. Okay, so let's find what this blue line is. Okay, so we have a y-intercept at 0, and what is our slope? What's our m value? So we go up 7 and we go over 2. So our blue line is just going to be 7 over 2x plus 0. We can just try to keep organized in that way. So we're going to have -2 and open circle. So it's going to be less than x and less than or equal to 0. Okay, what about this red line? We have a y-intercept at -3. What's our slope? It's going to be -2, 1. Okay, with that y-intercept at -3. So hopefully this is making sense on how I'm finding these actual functions. And this is defined from 0 okay, and we have this green line. And I don't see any y-intercept, so we're going to have to use our point slope form to find this. And remember, that's y minus a point y, a value y. Let me just write something out real quick. When you're using the point slope form, this is important to know. Okay, so now let's plug in some values here. So we have y minus a -7. What's our slope? We can find that out real quick. All right, so this distance is 5, and this distance is 7. So this is going to be 12, and we go over 5. So 12 over 5, x minus 1. Okay, and we're using this point 1, -7. Okay, so let's simplify this. This is going to be y plus 7, and I'm going to simplify this to 2.5x minus 2.5, and it's going to be easier when I subtract this -7 over, right? Okay, so we're going to have 2.5x minus 9.5. And this will be defined from -1 less than or equal to x, and x less than or equal to 6. Okay, so hopefully this is making sense. Really, at the end of the day, piecewise functions, it's kind of like a puzzle, a piecewise puzzle, right? And you want to combine it under one function, your piecewise function, right? These are each functions, but they're defined on a certain interval, okay? And well, this piecewise function is defined over this whole interval. So hopefully that makes sense on how to differentiate between just a function and a piecewise function. If you enjoyed the video, please like and subscribe.